Okay, in this video we'll show you how we can import a DXF file and then take it through into the Lathe module. Okay, so I'm in our 2D CAD module at the moment, and this is the DXF file that's been imported. A couple of things we need to do. Firstly, we need to get the orientation right, so what we'll do is we'll rotate, choose an angle, and then on that area we'll make it minus 90 degrees. What that does is it changes the sizes round so that we're now looking at it in the ZX plane. If I go into properties here, I can resize the paper to fit the drawing so that that now is the drawing that we've got. This line here I assume is the center of the component, and that's where we need to establish a 0 position. But before we do that, we just need to draw 2 extra lines at the 2 ends of this so that we can create a solid shape. So if we go into line mode, angled line, and then set our angle to 90 degrees, and then snap that line onto the end of those 2 elements there, and then we use the intersect routine just to trim those lines, and the same here. So what we've now got is we've now got a shape which is going to be the front, the profile and the back. If we just had the profile on its own, it would be ambiguous as to whether that was an internal or an external feature. So the next thing is to create what we call a profile, which is similar to a polyline. So we use the big red NC button, and the first thing to do is to set where we want the datum point to be. So this will be our 0 position in Z and X. Then we produce the profile, so we say this is the start of the profile and that's the end of the profile, and that then produces that profile for us. So we can now save that drawing away, and we'll take that into the CAM system. So this is where we do the selection of the tools, set the speeds and feeds, and choose which machining operations we need to use. So as it's a new job, we get to machine setup, so we need to check on the tool change position. So we can either use a front or a rear turret, depending on your machine configuration. We can set up a maximum spindle speed, so if you have constant surface speed control, we can use that. So the way the software is laid out, we have tooling definitions and program operations here on the left hand side, which are currently empty because this is a new job. The main graphics area is in the center, and our machining operations are all chosen from the bottom toolbar here. So the first thing is to define a tool, and we choose whether this is coming from a front or a rear turret and whether it's a front or a rear approach. This depends on your machine tool. And then this is a standard CNMG tip with 0.8mm. If we wanted VBMT, for instance, which is 55 degrees, or sorry, DNMG, or a VBMT, which is 35 degrees, then we can set that there. So depending on the tool tip dimensions, you can set this up here. We can also set up a tool library, so that once you've defined a set of tools, you don't need to define them again, you can just call them up for use. So that's defined the tool we're going to use. Now we need to select that tool for use, and this is where we set the spindle speed and the feed rate. So if we have constant surface speed, we can use it here. So let's have, say, 250 meters a minute. If we're working in imperial, then this would be feet per minute, and then the feed rate can be output as feed per minute or as feed per rev. So let's have that as feed per rev, and if we need to use the coolant, we can switch that on here. So that's defined the tool and selected it for use. So now we can tell it what we want it to do with that tool. So the first thing we'll do is a rough turning. So we give it the cycle limits, which are the 2 corners of a rectangle where the tool will work between. So let's assume that that's going to be the start point, and the end point is far enough at the past the end of the material and low enough here so that it takes into account that scallop. Finishing allowance, if we want to leave a finishing allowance on here, then we can do, and the maximum depth of cut for that tool, let's say 2 millimeters. So that produces the tool path for that tool, and that's using just the tool envelope. If we want to animate the tool, then we can use that here. The dotted lines are rapid motion and the blue lines are feed rate. So we can control exactly where the tool is cutting by specifying the start and end points of the rectangle that we want to use for this tool. So you'll notice that the tool won't overcut the profile, so it'll only cut where the tool geometry will allow it to. So that's produced the roughing pass. We can use the same tool, or we could use a separate tool for the finishing. If we want to use a separate tool, then we simply define a new tool, and this time we'll call it a finishing tool, and we might have a smaller tip radius on that. The Z and X offsets here are all automatically applied based on the tip radius. So now we select that tool for use, set the spindle speed and the feed rate for that tool, and the finishing operation is done with an operation called profile turning. So this is an external cycle and we're cutting in the forward direction. If we want to cut just particular parts of that profile, then we can specify that in the options page here. So the spans are numbered automatically, so this would be span number 1, 2, 3, 4, 5, 6, and this would be 7 down here. So if we want to start at span number 2, because we might not want to machine the front face, we start at span 2, and if we want to finish along this face here, that would be span 6. So we go to the profiling operation now, and we'll add on a parallel approach of say 3 millimeters, and we'll have a parallel runoff so that it starts and ends 3 millimeters off of the actual part. Okay, so that's moved the tool to past the end of the shape there. So to take that tool back to its home position, we use the go to command. So we're going to send it to the home position, but we're going to move in the x-axis first. So it pulls up off the job and then back to the tool change position. So if we're happy with that, we can post-process, and we'll use the Wabaco machine, and that opens up a further window at the bottom here, and that gives us the G-code for that. If we want to, we can use the 3D simulation module. This is a standard lathe configuration. So that now produces the data to pass through to the machine tool simulator, and we can see the two tools that we've got there. If we want to, we can set up a complete tooling library with tool tips, holders, and other information. So we accept all the defaults and click the simulate button. So that loads the machine tool simulator and passes through all the list of X and Z movements, and then we have simple video controls here. On the right hand side here we can see a list of the individual operations. Okay, so that's job completed, and we return to the CAM module. All the files are saved away automatically, and then we can transfer that G-code file down onto the machine tool controller.